When you're doing horizontal partitioning, you need some logical and consistent way to figure out which rows go into which shard. Remember that you'll want to keep each shard roughly the same size. And to keep your application code simple, you'll want the shard assigning logic to be simple as well. Something you could easily implement in several different places in several different languages. Let's go through a few common horizontal sharding methods and discuss the pros and cons of each. The first is called round-robin partitioning, which is a simple strategy that ensures uniform distribution of rows between shards. This uses a bit of modular arithmetic, so let's quickly review it. When you divide two integers, you get a quotient and a remainder. The dividing operator gives you just the quotient, while the modulo operator gives you the remainder. For example, 23 divided by 4 is 5, remainder 3. So you can write that as 23 modulo 4, or just 23 mod 4 is 3. In many programming languages, the modulo operator is implemented with the percent symbol. So you often see that used as a shorthand. Meanwhile, in more formal mathematics, the symbols are shuffled a bit, and we write that 23 is congruent to 3 written with a triple equal sign, mod 4. These are all different ways of writing the same exact thing. We use the modulo operator in round-robin partitioning. Suppose we have n shards. When a new row, call it row number I, comes in, we assign it to the I modulo nth shard. Let's take an example. Say we have 4 shards. The very first shard, which would be I equals 0, goes in shard 0. Next goes in shard 1, then shard 2, then shard 3. Once we reach the 5th shard, I equals 4, and we start over, since 4 modulo 4 equals 0. We just repeat this process over and over, and we'll have a roughly equal number of rows in each shard. Plus, since the logic is so simple, it's easy to look up which shard a particular row is in. Just take its row number, which is the order in which it was added, and modulo it by the number of shards. There's another very simple sharding strategy called key-based sharding. Like with round-robin, it uses the modulo operator to assign rows to shards. The only difference is that the row's unique ID, which is often a large number, a large random number in fact, is passed through the modulo function. Because the IDs are randomly distributed, the number of rows that goes into each shard should be pretty even. In other cases, the unique ID is just an increasing integer, 0, 1, 2, 3, and so on, in which case this is exactly the same as round-robin sharding. The main difference is that database rows almost always have a unique ID, while they don't usually store the order in which the rows were added, making key-based sharding a bit easier to implement than round-robin sharding. Another related but more complicated way to do sharding is to pass some other bit of information about a row, such as the product's name, a user's phone number, or a car license plate number through a hash function, which outputs a random-looking large number. Then modulo that by the number of shards you have, and you'll again get the shards with the balanced distribution of rows. It's a bit more complicated than key-based sharding, and it doesn't have many advantages, so we recommend just using key-based sharding over this one. Now, the problem with all of these methods is that you're basically fixed to a certain number of shards. If you want to add new shards, you have to modulo by a new number, say going from ID modulo 4 to ID modulo 5. That will change the shard assignment for pretty much every row, which makes you move all your rows over to their new homes. Redistributing all of this data thus requires downtime each time you want to increase the number of shards, which is not great when you're scaling up. One alternative to these methods is called range or list-based partitioning, where we separate rows based on some attribute. Our earlier example of sharding by country was an example of this. To implement this, we look up a particular value for each row and define some rules for where the row should go based on that value. For instance, we might assign Norway, Sweden, Denmark, Finland, and Iceland to a single Nordic shard, while giving the larger US its own shard, and putting Australia and New Zealand on their own shard. Now we have a list of values that defines each shard, which is where we get the name list-based partitioning. Alternatively, for numerical values, we could assign a particular range to each shard, which is where the name for this method comes from. For instance, users whose birth years are between 1980 and 1990 could go in one shard, whereas users with birth dates that are between 1990 and 2000 could go in another, and so on. This method can work great if you can carefully craft a list, ensuring that roughly an equal number of rows will go into each shard. But if you get the splitting wrong, it won't work that well for you. You'll get some unbalanced shards. And even if your splitting works well on the start, it might get worse as time goes on. For instance, say you initially put Japan and South Korea on the same shard, and that shard is pretty reasonably sized for a while, but then a flood of new users comes in from South Korea, and suddenly your shard gets way too big. So with all these methods, we'll eventually have to rebalance oversized shards or add or remove shards as we scale. We're going to tackle that problem in the next lesson.